Okay, now we are in question 2. Okay, question 2, part A, and the first bit. They are asking us to use the information on this diagram and to discover what is the distance between these 2 points. Okay, there are different ways to do it, but what I want, or what they want you to realize, is that you got a distance between peak to peak. Okay, and the distance from peak to peak is called the wavelength. Now, we got the wavelength, okay? And wavelength is how long is one wave. And then you have to observe, and how many waves do we have here? We got 2 waves. We got one full wave, the first one, and then the second wave. Therefore, there are 2 waves here. And how long is 2 waves? 3.2 centimeters. Okay, therefore, if I want to know one wave, what I have to do is 3.2 divided by 2 equals 1.6. That is the length of only one wave. And I got centimeters, and I'm going to check the units. We are not massive fans of centimeters, but they are asking us to place the result in centimeters. Therefore, I got 1.6. Okay, and remember, I'm going to change color. This is the wavelength. Why this is important? This is going to be very, very relevant in the next question. Now, what are they doing here? They are giving to us some information. A wave takes 5 seconds to travel 40 centimeters along the surface of the water. Now, use equations from page 2. Okay, we need to go to the famous page 2 and the information about to calculate the frequency of the wave. Okay, cool. We need to calculate the frequency. We need the frequency. Then we will need an equation involving frequency. I'm going to make question 2. Current, with any current here, total resistance, no energy transfer, power. Look, I got frequency. I'm going to be using this equation because I got here the frequency. Okay, wave speed equal wavelength times frequency. Okay, therefore this equation, I'm going to use it here. That I got. The wave speed is equal to the wavelength times frequency. Or writing it with symbols, V equals lambda and frequency. Now, I want to leave the frequency alone. Okay, we need to calculate the frequency. Therefore, lambda, this wavelength, I need to pass it to the other side of the equation. If is multiplying here the frequency, how does it pass on to the other side of the equation? Dividing. Okay, sorry. Lambda. Now, so far, do we know how much is the wavelength? Yes, we got it here. Okay, this wavelength is this number. Okay, therefore I got here speed times. Now, but what is our problem? We need to calculate the speed of the wave. Okay, the speed. Now, and we don't know how to do it. However, they are giving to us an extra information that the wave travels 40 centimeters in 5 seconds, and that is equal to the speed, distance over time. If you don't remember this equation, don't worry, you got it here. Speed is distance over time. Okay, and here what we got, distance over time, we got 40 centimeters divided by 5 seconds. Okay, take my calculator, 40 divided by 5 equals 8 centimeters per second. Now, I got that number. Okay, that is going to be this one, and I place it 8, 1.6. Now, what I want you to be careful, just in case they mess around with the units. Here we got centimeters, and here we got centimeters. Speed we got centimeters. That is why we don't change units, because we are calculating and operating with the same units. Therefore, we don't have to worry about the units here. And we only have to do the calculations. That is 8 divided by 1.6, and that is equal to 5 hertz. And I write the answer 5 hertz. Okay, that is how we do this part of the question. Next, wavefronts. Okay, they want you to complete the diagram. We have done a very similar diagram during the lessons.